Once you've made the decision to make mats, the next question is, what dimensions are you going to make the mats to? Well, this is a typical Lanston monotype flat mat, and since you're most likely going to be using monotype equipment, you probably ought to make the mat to monotype specifications, and they are very precise. The first thing about the description of the mat is at the corners, the upper left hand and the lower right hand corner, they're chamfered so they can be held into the mat holder properly. And the dimensions right, left, and up and down are very specific too. Using the point system, the mats are about 82 points tall and 54 points wide. Well, the next question is, where does the image go within this area? Looking at Lanston mats, you might make the bad assumption that the images are placed on the matrices in a rather haphazard fashion. There's a 14 point, there's the 18 point, there's a 24 point, which looks like it's a whole lot lower than the others. 30 point goes up a little bit, and 36 point goes up even further. Is there any sense to this? Well, the answer is absolutely yes, and that if you don't position the letters properly within the frame of the matrix, then the person running the casting machine cannot get the letter on the body properly, because the molds are different and you have to match the mat to the mold in the machine. So where do you go to find information of this nature? Back in 1988, Paul Dunsing put this publication together, and it's just filled with the technical information necessary. And there's a date, you can see it right there, and right over here on a couple pages into the publication, and here you see Table 4, the American Display Matrix, giving the side bearing, head bearing length and width, and also depth. There is the schematic, and right below is information dealing with the head bearing and head side bearing for the various molds, and all of Paul's information is in points. Therefore, I have detailed information telling me exactly where I need to position the letter when I'm making an electrodeposited matrix. Since there's an abundance of matrices on hand already that are made to the dimensions that Lanston wants them, and mats for faces that you're no longer interested in, I have hundreds and hundreds of mats. I've made the decision to reuse these mats, and so you can see in the back where the copper has been deposited within the brass frame. So if I'm going to make a 24 point letter, I'll use a 24 point mat, and now I need some means of telling myself how to come up with a frame to hold this blank matrix over top of the character so that everything will be deposited properly. I'll show you that now. The first step is to drill out the matrix. I'm back at my drill press, and I'm about to take this matrix and drill it out. What I want to do is, I've chosen a mat, a 24 point, because I'm going to be making a 24 point letter, and I'm going to drill out the part which is right now electrodeposited in this brass frame. I've drilled the character out. Please note that I did put a block underneath it so that I would not be putting pressure on the mat in some strange way, and therefore bend it a little bit. And now that it is drilled out, you can see the hole, there's where it was. Now I'm going to lock this character up in here and get a different tool in my drill press for milling it out. I use two different reamers for this purpose. This one right here is tapered, and this one is a ball on the end. The first tool that I'm going to use is this tapered reamer, and I'll put it in the chuck, lock it down, and I've also sped up the RPM of the drill press itself. This tool seems to work. Okay, what I'm doing is just putting that taper down into the hole that I've drilled out and then locking it there, making sure before I turn it on that it's not touching anything. And by the way, I hold this vise very tightly to make sure it doesn't get away from me when I'm doing this. Turn the drill on. What I'm doing is cutting the hole bigger. I now have cut it out. In studying some Lanston mats that fell apart on me, I discovered that Lanston had a flange, a wider area around the outer side, and that was to give the electrodeposited part a little bit wider breadth at the back and give it a little more strength, more holding power into the thing. And I find that I can do that by taking this ball tool and lowering it about half the distance down in the hole. And now I'm going to just go around the outer edge with the ball tool to put a flange on the outer side. So now what I have is a matrix cut out on the back side with a hole that's much bigger and it's tapered. And on the front side, I'm going to have to touch it up with a file, but it's perfectly flat on that side. From the information I got from Paul, I worked out this little scheme to tell myself how to make shoulder level quads to the right dimensions for a 24-point character, and that's what I'm dealing with. First thing I need is a quad that's 24 by 32, and so I would put that right there. And then I need to go beside that a 30 by 32, so 24 plus 30 equals 54. That's the total width. The next row, I'm starting with an 8-point side bearing, which is consistent. That would go there. And beside that would go the character itself to be deposited, which in this case is a border element from the Stempel Typefoundry in Germany. It's a 24-point casting. And then to the right of the character is what I call a variable space, and what I do is take the 8-point character, the letter to be deposited, and in a wider character such as a 36, put it in there, put the whole thing up nicely in my Hammond glider saw, and then I cut the thing off to the side to 54 points exactly. So this quad has been cut off so that it will take up the difference on the right hand side, and that's the reason I have variable written on that character. And then the bottom row is two 24-point characters, both cast to 27 points in width, and 27 plus 27 would equal 54. And so there is the block that I will assemble to make my character in the right position when electrodeposited into a frame of a Lanston mat. I do my assembly in a composing stick just like I would set type. And so I'm going to start for the 24-point with a 24 by 32 in place and a 30 by 32. I have placed at the top a piece of rule, which is 0.918 tall. It's 6-point. And both sides I've got rule in there to serve as guides in the placement of the hollowed out matrix. The next row is going to be the 8-point side bearing, which goes in here, and then the character to be deposited, which goes here, and the piece, the variable space piece that goes in here up against it on the side. And the last row is a couple of 24-point quads that are 27 points wide, total of 54 points wide. And so there is the assembly. Following immediately after that is a matter of tying it up. And I tie it up with regular kite string Kite string is really small or thin, but it's very strong. I start the kite string, I don't know whether you can see it or not, but I've tied a knot in the end of it, and I hook the knot on the corner to keep it from sliding, and go around the form about 3 or 4 times as tightly as I can. And at that stage I feel free that I think I can take it out and hold it in my hand, and I'll continue tying as tightly as I can, string around the form. This is going to hold it together during the electrodepositing process. So I'm continuing to tie just as tightly as I can. Doesn't hurt for the string to overlap itself. When you get to the end, you tuck it in just like you would tuck it in with a regular type form. And I'm using a pair of tweezers. Take the end and tuck it underneath the other stuff. And then I'm going to look at the other end and make sure that the beginning end is also tucked. Now you see my block is holding together. It's not going to fall apart. Everything is held tightly in place. I'm checking now to see that my hollowed out matrix is going to fit in place properly. And I've just laid it down on top of the form. It fits pretty nicely. The important thing here is that there's plenty of space above and below on the right and the left, so that the electrodepositing process gives me some copper all the way around. The bearing surfaces, which are most important, is the left side, which is right here, and the topless is right here. But I also use a bearing surface or a flange on the right hand side that just gives me a better feel for whether the mat is right. Most Lanston mats are exactly 54 points wide. This one's about 53.5, and so there's a little bit of wobble, but I'll be pushing it all the way to the left side when I actually put it together. I also have discovered that this particular character has a deeper drive than 50 thousandths, which means that the flange at the side of the character right here goes down beneath the characters in my block. I feel that's going to be a little bit rough to deposit down in that hole, and so I'm going to hone it out around this character to give me more space, so I have a better deposit down on the sides. I have cut away on the sides closest to this character a little bit so that the copper, when it deposits in, will have more of a chance to get down in on the edges, which are below the height of a 50 thousandths mat. Of this character is probably about 60 thousandths, and I wanted to make sure that I got a good deposit way back down in there. I will be rubbing that away when I dress it, but if it didn't make a good deposit, then I would have a faulty mat. Next is to make sure that the frame, which there's a top, that it goes down on top, fits very nicely. Everything's open all the way around, and there's plenty of room for copper to get down in there. Next comes the issue of leveling. This is probably the most critical aspect of making this frame and getting it together, because in this leveling process I'm establishing to a very large extent height to paper. These mats are going to be 50 thousandth drive, and in order to accomplish that I have come up with a piece of 4-point brass rule, which you see right here, and I've cut it out so that it can be sort of a universal frame. Put the micrometer on the 4-point brass rule and came out to be 55 thousandths deep, and I rubbed it down, that's why it's so shiny. I rubbed it down on both sides until it's 53.5 thousandths right now. So I've got 3.5 thousandths. In finishing every mat you'd have to do a little bit of rubbing, but I think that 3.5 thousandths is plenty. I did a couple of mats originally before I rub this down, and I'm just trying to eliminate some of the rubbing on the finished mat. And so that piece goes right in there, and then I work on an absolutely perfectly flat surface, and I'm using here the stone. the steel stone that I use for leveling forms for the press. Take the whole thing and invert it, and make sure that my blank brass rule stays in place. And now I'm going to very, very carefully, with something blunt, I'm making a real strong effort to push every character. That was the character itself. I think you may have seen it depressed just a little bit as I pushed it. But I'm pushing every character down just as hard as I can to make sure that I'm leveling everything. You can see a little bit of a flange right here, which means that my piece of type, in this case it's a piece of European type which has been milled, and so we don't really know exactly how high it is. It doesn't make any difference. I have now pushed it down, and so I've got the 53.5 thousandths depth assured on that character because of this frame right here. My tie-up is very tight. Nothing is going to move around unless I put some undue pressure on it. And so this form is now leveled. Of course, I checked everything to make sure there was no burrs or anything like that to interfere with the leveling of this thing. Now the blank matrix goes on top of the form right here, like that. And I have to have some way of securing that also. And again, I use kite string. First, I make sure that the drilled out mat is to the left side and to the top. And I hold it in place with my thumb. And I get the kite string and start wrapping on this edge just like that. Not a great deal of pressure being put on because I don't want to foul up the leveling that I've done. I've got far too much string here, but I'm not going to take time to cut it. And the string is wrapped around it like that. Okay, just like I did before, I'm going to tuck it in. Up on the top, I'm going to actually move the string away from the deposit area a little bit, and you see that I have the string sticking out here. I'm going to tuck it in also. It is tucked in. I'll double check again to make sure the mat is over to the side and to the top. And so that's going to hold it together. Everything is in place. Now I'm ready to paint this together. And what I use is a product which is called liquid electrical tape. This material goes on, and the two purposes. One is to hold it together, of course, but the most important purpose of the liquid electrical tape is to keep electrical current from passing through on that particular point. This tape, this liquid electrical tape is kind of old, and therefore it's more viscous than a new can of it would be. But I'm painting in just as close as I can without getting into the hole. This cannot be accomplished in one pass. You have to make 2 and 3 stabs at painting a block together, because ultimately you want every portion of this thing fully covered with this material. Of course, I'm trying to cover the string completely, but I don't think I'm going to. Yeah, there we go. I got a little glob. Paint this thing in. I'll let it rest for a little while this material sets up, and then I'll go back and get the bottom. Yes, it worked fine, but I did not get any of my electrical tape on the area that needs to be deposited. That's going to be part of the final deposit. And while I have this out, I'm going to do a little bit of work on the sides, which I'm doing now. This electric tape will actually become, the string is going to actually become a part of this tape. And it'll, when I tear it apart after it's all done, it comes apart in one nice piece. It's not a big mess at all. It peels off very easily. That's as far as I'm going to go with the painting. You get the idea. As soon as it's set up on this side, I'll turn it over, paint the bottom completely. Everything is being held in place by the tightness of my string around it. And so far, I've had very good luck with that. I'm back at my drill press, and what I need to do now is drill my block so that I can hang it in the electrotyping soup. And so I've got an 1/8" drill in there, and hopefully I've drilled the block so that all of my drilling goes into the quads around the piece rather than the piece itself, and I think I did all right. The next thing is to take a piece of standard number 12 wire and strip it and make a hanger. And I make the hanger by stripping the end of the wire where the wire will hang onto the electrotyping system, and the other end that goes into my block. That being stripped off, I now take my block, and hopefully that will fit right in the hole. Yeah, works fine. Now I'll bend it up so that my piece can hang. Looks pretty good. And I have a fancy pair of pliers here which enable me to make a nice rounded hanger to go on the end like that, and that will go in the electrotyping soup. The whole block will hang down, and this whole part will be submerged in the copper sulfate sulfuric acid compound. And what I need to do now is go back and do some very final touch-up with the electrician's tape, getting it around where I put the hook into it, and a few spots that I see are still open. Otherwise, those spots will deposit metal also, and I don't want that to happen. Here's the power source that I have. It's set for 3 volts right now, and I'm reducing it further at the system. It's just a regular thing that you buy at the Radio Shack. Mike Anderson's provided this to me. Here's my depositing tank. It's a plastic tank with 2 copper rods stuck in it, and you see over here at the side my means of checking the voltage, and I can increase or decrease it by turning this. 1.25. I'm trying to keep it about 1.4, so I want to increase it just a little bit. 1.37, 1.38 is close enough to 1.4 as far as I'm concerned. So my voltage is about the right. The voltage will change. It will increase as the amount of copper being transferred changes. Here is a tank which I keep covered at all times except when I'm working in it, in case something wants to fall into it. I don't want that to happen. And there's my blue solution. Over here on this side is the source of my copper, which is a little block of copper hanging down into the solution. And over here I actually have 3 mats growing. You see the mat right here? This one's been in about a week and a half, and you can see the area that's grown quite a bit. See the little spots around on the edge? The copper finds a way of making electrical contact, and it grows. And even back here on the back, I will go back and touch this up to further insulate it from transmitting the power, because I don't particularly want to deposit copper out on the outer edges. But that one's coming along very nicely. Compare that with this matrix here. You can see perhaps that it's a numeral 3. That one's been in about 3 days, and so the amount of copper that's deposited is much less. Here again I have a couple of spots where copper has grown, With the electrician's tape, the liquid electrician's tape, I can paint it on there and put it right back into the suit. Here you see the mat that I have been putting together, or the block that I've been putting together. It's got the hook on it. I now have liquid electrical tape all the way around it. It's ready to suspend, so I'm going to start the process of making the mat right now. No, I'm not going to, because I just spotted an area there that needed some more electrical tape on it. Otherwise I would have had a big spot growing there. The nice thing about this electrical tape is, liquid electrical tape, is that you can put it on there. You don't have to wait for it to dry. It'll dry even if it's suspended in the solution. So there she is. She's down in the soup. And sometimes, or I always take it down and then put it back real quickly, just to make sure that I don't have a bubble of air on the face of the character or something like that. So now I have 4 mats in the process. One of them's been in about 3 days. One of them just went in, and 2 of them have been in about 2 weeks. I do keep a log to let me know what's in and how long it's been there. And so you see the process of electroplating has begun.